Which points did you start with?
2O.
So you started with 2O.
It's tested to see if that's positive or negative.
So at y dash. Oh. So which one did you substitute that into, first of all?
C, because I thought that would be the one that would be negative, but I tested with A and it was positive. So
Okay.
Right here.
So well, how do you think about testing one point into each of these four equations here?
Just whack, like, again, like do 2, and then
Yeah.
you can see which one's positive and negative, and
Okay.
just roll those out. Then you already have ruled 2 out. So then it should only be one of those 2, and that rules the other one out.
Yeah, so when you look at them, right, the equations are designed in such a way that elimination should be an option. Like the process of elimination should be an option, right? For example, A, if you look at A, if you put in x equals to 0 here, what do you notice? That's going to be negative. But you notice here at the origin, it should be, that's not what I wanted to do. At the origin, it should be positive, right? So that's something to note. At the origin, positive gradient. So which ones do you cross out, Harry? A and B. Right, because if you look at B, same idea. If you put in y is equal to 0 here, then you're going to get a negative value, okay? And then from there, you have two options.
Cross out D.
Why do we do that?
Why?
Why? Because why? Exactly, why? Say that again.
Stuff doesn't change order. So why doesn't it affect?
Right, so here's the observations I want to get you thinking of, right? You notice, first of all, in either of these equations, there's either no x or no y variable. And think about what that means. Here, if there's no y variable, that means that the gradient shouldn't change going across the axis. And here, what does that mean? The gradients don't change based on the y variable, so going up or down.
So why'd you write okay?
It's don't going. There we go.
I have the other one.
Right, so then you look at these and you're saying, okay, the gradients don't actually change when I change the y values, yeah? So that would make sense then that my answer for this one doesn't have a y variable as well. And it makes sense that it would be C. I would still test in a few other points just to check. Did you guys test any other points out of curiosity? Or no? Okay, I think it's still good practice just to test other points. If we wanted to test, for example, I don't know.
I mean, you did 2. That's like
-1 if you just wanted to test, right? What would y dash equal to according to this equation? It would be 3 minus 1. So what, 2 on 3? So it should be positive at -1, 1. And yeah, that looks like it's positive. Another thing that I didn't mention, but it's good to have a look at, right? If the gradient at the origin is just +1, and this one's meant to be 2 on 3. So this gradient here is meant to be 2 on 3. And this is meant to be +1. Do you think that this graph kind of reflects that? If you look at the actual isoclines on your one, it should be subtle, but it should be clear that the one at where it's meant to be 2/3 is slightly less steep, right? And that would make sense because 2/3 is a smaller number than 1, so the gradient should be less steep than that, okay? So that's another thing to observe, like that one is actually less steep if you kind of look at it a bit more closely. Yeah?
You're saying less thick or something?
No, yeah, they don't use thicknesses in that one. Yeah, so less steep. Okay, cool. All right, next one. Did we have a go at this one? Okay, so let's check 0, 0. Are they all the same? I think they are all the same. It's not bad to sub it in, right? It's like things that are easy to check. If it's easy to check that they're all the same, then you haven't lost much time on that or anything. You can sometimes eliminate them, but in this case we can't, unfortunately. That's okay though. And the gradient you can see is actually horizontal there, so that all kind of checks out. Okay, what about another point, Eva? What's another easy point?
1, 1.
Yeah, let's try 1, 1. So I sub in 1, 1. And at 1, 1, just have a mental note that your gradient should be positive, right? Should be positive here. And if I go back to these ones, let's have a look. This one I get, what, A. So how do we want to do this? I guess I can think about, what if I do it like this? If I go at 1, 1, and I'll write what all the gradients are at these points, right? So what have we got here? We've got 3 on 2. Half. This one gives me, again, 3 on 2. And this one gives me, oh, this one's different. This is -1/2, yeah? Okay. And we know the gradient should be positive, so we can already rule out one of them. Yeah, go to D. Okay, what about another point? Or what else? Well, what other things are you thinking of? 1, 2? Yeah. Yes, and 1, 2 is good because look at 1, 2. It should be 0, so that's an easy one to check. So let's put in 1, 2. And I only have to check 3 of them now, which is nice. So if I put in 1, 2, what does that become? 2? It looks like it's going to be 2. This one looks like it's 0. And this one looks like, oh, yeah, go away. That's only 2.5. Why not? There's only one of them that's 0. Okay, yeah, of course. Naturally, right. So B looks like it's the best option here because these ones aren't. And again, it'd probably be by good measure. If you wanted to, you could check one. But I think at this stage, it's pretty conclusive that just make sure you test this point properly. That 1, 2 here, that's the only one that should be 0. Make sure you've substituted all the points.